understood the lectures of calculus so far and are clear with the concept of derivative, rate of change, the difference between instantaneous rate of change and average rate of change. And then from there on, moving on to differentiation, from which you have understood how to differentiate a given function to calculate what is called its derivative. And from the derivative, how we can find the instantaneous rate of change or slope of tangent at a given point. And the last lecture, we discussed some important techniques of doing differentiation of more complex functions. Like we discussed about product rule, quotient rule, and most importantly about the chain rule, which is applied for composite functions. So let's take the discussion from that point onwards today. So we'll do a quick recap of the concept of chain rule application. And from there on, we will maybe look at some of the questions in the homework assignment which I had given you. Especially if you have some doubts in those questions, etc. I have sent you the answer key with hints today. Okay, but still we will discuss some of those questions, how the exact application of particularly chain rule wherever applicable, that is done over there. Okay. Okay, so let's start with a quick recap of composite functions and their differentiation by chain rule. So in general, a composite function is a function of this type where the dependent variable is connected to the independent variable by, you can say, two layers of functions. That is, on x, we first operate the function g. So we get gx. But then on that, we operate the function f. So we get f of gx. And that becomes what is y. Okay. It's a two-step, you can say, two-step operation to find out the value of y from the given value of x. So for example, if I have the function y is equal to, let's say, square root of, or we did a square root function last time, so let's take something else. So suppose we have y is equal to e raised power sine x. Now this is a good example of a composite function, because what we have done is, here from x we have first operated sine. We've operated the sine function, so we got sine x. Okay, and then on that we have operated the exponential function. So we've got exponential of what? We've got exponential of sine x, and that is the value of y. So this is our g. So gx is sine x, and this is our f. So f of gx is equal to e raised power gx. So that is nothing but e raised power sine x, which is our value of y. Okay, so this is a typical example of a composite function. Okay. Now I told you that to differentiate a composite function, we need to use a special technique called the chain rule. So let's go over the steps of the chain rule again. So differentiation of a composite function by chain rule. So let's see how that works. Okay. So it's a three-step process, as I told you. So to differentiate by chain rule any function of the type y is equal to f of gx, and let's side by side also look at the example that we took. Y is equal to e raised power sine x. Suppose that was our example. So you can see that the first step that we will do is introduce the dummy variable, and that is called the substitution step. That is, introduce a dummy variable. Let us say in this case Z is the dummy variable we are using. You can use any other symbol also like U or T or whatever. So I've used the symbol Z. So let Z be equal to Gx. So automatically that implies that Y is equal to F of Z. So applying that step over here in this example, substitution step will be like this, that we'll take Z as sine X. So sine was the first thing we operated on X. So that is the G over here. Okay. So immediately what happens, our Y becomes very simple. It becomes e raised power Z. Then the second step was the actual chain rule concept for differentiation. So we implement the chain rule in the second step, that rate of change of Y with respect to X. Now see what is happening. Y is no longer directly related to X. Y is related to Z and Z is related to X. So the relationship between Y and X will be defined as the rate of change of Y with respect to Z multiplied by the rate of change of Z with respect to X. So this particular formula is the formula that defines the chain rule. This you can see is the chain rule step itself. Okay. So now let's implement this step. So we get dy by dz will be differentiation with respect to z of fz multiplied with differentiation with respect to x of gx. So we can write this as derivative of f applied to z with derivative of x. So in this particular example that we have taken, this step will now become like this. Let's implement this second step over here. So to implement this step, now we have to substitute these things. So this is differentiation of the function e raised power z multiplied by differentiation of the function sine x. So you know differentiation of e raised power z is e raised power z itself. So we've reached the end of this step. Now the final third step is the re-substitution step. Okay. So in that we again re-substitute the value of z in terms of gx. When we re-substitute, we get this relation that dy by dx's final value will become derivative of f of gx multiplied with derivative of gx. So this, whatever it comes out numerically or whatever it comes out in terms of the actual given functions, that becomes our final answer. Because z was a variable that we introduced as a dummy, so it has to be eliminated here. So f prime z means z has to be replaced with the relationship with x. So that is nothing but it is gx. So when we implement that over here, you can see this is the re-substitution step. We will re-substitute this here. So our step 3, this will just be dy by dx is e raised power z ke jagah it is sin x into cos x, which we can write in a more convenient manner as cos x into e raised power sin x. So this becomes our final answer. Okay, so just go over these steps very carefully. On both on the left hand side, how we have defined the steps, as well as an actual.
Explain this one more time.
Let me know if there's any doubt to discuss.
Sir, can you explain this chain rule one more time?
Yeah, so just go over these steps. Okay, we will discuss with more questions. Okay. If there's any doubt in a particular step, just tell me now where you have not understood. Just go over this again.
Step 2.
Yeah, step 2 is the definition of chain rule, that rate of change of y with respect to x is equal to rate of change of y with respect to z multiplied by rate of change of z with respect to x. This is the definition of the chain rule. A very simple thing. Now you can see you want to find what is dy by dx. It is a change in y upon a change in x. So that can be replaced as a change in y divided by change in step. Is it clear now?
Yes, sir.
Okay.
वर्जन भी बोलते हैं, उसको आप कैसे डाउनलोड कर सकते हो। वाली वीडियो में मैं आप लोगों को बताने वाला हूँ कि आप पबजी मोबाइल कोरियन वर्जन या जिसको हम लोग पबजी मोबाइल
Sambhavi, you have asked the question, why didn't we take e raised to z as 1 by z? Because that is not the definition of e raised by z. Beta. 1 by z is a different thing altogether. 1 by z is the inverse function. E raised by z is the exponential function. They are different things. Right? E is that irrational number whose approximate value is 2.7. So for example, e raised power 2 is approximately 2.7 raised power 2. It is not 1 by 2. No? Okay. All right. So I'm now assuming the steps are clear over here. Okay, both on the general definition left hand side as well as in the example I've taken of this particular function y is equal to e raised power sine x. Okay. Now, since we have covered quite a few things in the last 3 lectures, today I want to devote some time to any doubts and questions that might still be pending from your homework assignments. Okay. So let's go back to, of course, we will discuss the latest assignment, the third one. But anybody has a doubt in the second or in the first worksheet, please let me know. We will discuss those. What is the derivative of sine 2x? Very good. We'll discuss that with you. Okay. So let's devote some time to doubts and discussions today. So we'll start with this question from Vidhi, that how do we differentiate the function sine 2x? So you have to understand that this is a composite function. Okay. This is a function where on x we have operated the function twice of. So we have got 2x. And on that we've operated the function sine. So we got sine of 2x. So basically you can say that gx is equal to 2x. And then f of gx is equal to sine of gx, which is sine 2x. So that is one way to do the differentiation. Okay, there's another method also I'll discuss. Okay, but that involves a trigonometry formula. But are you clear so far?
Yes, sir.
Okay, so next step, what we have to do to differentiate here, you just apply the chain rule concept. So step 1.
Sir. So suppose y is equal to sine 2x, then the derivative of y will also be equal to sine 2x.
No, it will not be. That's what I'm explaining over here. Just hang on a second. Okay, I'll explain it properly. Okay. So the first step is substitution. So on x, what is the first operation I've done? Gx, which is this now. So I should substitute z as what? 2x. So this is my dummy variable. Okay. So immediately what is y becoming? Y is becoming sine z. Okay, so this step is clear?
Yes, sir.
Okay, so now it's very simple. You have to just follow the remaining steps. So chain rule. So rate of change of y with respect to x will become rate of change of y with respect to z into rate of change of z with respect to x. Okay. So now you can see y is sine z. So when you substitute that, what is differentiation of sine? It's cos. So this term becomes cos z. And you can see z is 2x. So what is differentiation of 2x? It's 2. So this becomes 2 cos z. And now finally re-substitution step. So here the re-substitution is very simple. Z is just 2x. So dy by dx becomes how much? It becomes 2 cos 2x. Okay. So this is one way of doing the question by using the chain rule method. Now, because you have an option with trigonometry here of also expanding sine 2x in terms of sine x and cos x, there is a second method also which I'll discuss. But in my opinion, this is the easier of the two methods because we don't have to really, like, expanding something just makes it more complicated. Okay, so this is the more easy method actually. So Both of you, it's clear, no?
Yes, sir.
Okay, very good. Now, can anybody tell me the formula of sine 2x expanded using trigonometry?
2 sin x cos x.
Sorry, can you just say a little louder? I could not hear you.
2 sin x cos x.
2 sin x cos x. Yes, that's very correct. Good. Okay. So this can be expanded using trigonometry formula, that it is 2 sin x cos x. So now what principle we can apply here? We can apply product rule also. 2 is a constant, so it doesn't matter. It's a product of two functions, so we can use that also. Okay. So this formula actually comes from the more basic formula of sine a plus b. As you know, it's sine a cos b plus cos a sine b. So therefore, sine of 2a just becomes 2 times sine a cos a. Similarly, another formula you have, that cos of 2a can be written as cos square a minus sine square a, which is the same thing as 2 cos square a minus 1, or it's the same thing as 1 minus 2 sine square a also. These are some formulae that sometimes come in handy. Yeah, I'm receiving some more questions on the text messages. I will come back to them. So let's also use this method here. So if I use the product rule here, so when I differentiate this side, 2 is a constant anyway, I'll take out. So differentiation of first function multiplied by second function plus first function into differentiation of second function. So you can see this will become 2 times cos square x minus sine square x, because now of course you have to always remember the formula of differentiation. So you should not confuse this, that differentiation of sine x is cos x, whereas differentiation of cos x is minus sine x. So that's how this minus sign comes. And now you make use of this formula. So it is equal to 2 cos. So now this is also something important, that for example, suppose you have gone with the second method and you come up to this answer. So you should not get confused that this answer is different from this, because you should understand that this and this are equivalent. It's just a further trigonometric simplification. Cos square x minus sine square x can be simplified as cos 2x. So hope both the methods are clear for this particular question.
So if we want it in terms of x, then we can just apply the expansion.
Can you speak a little bit louder, but I cannot hear you. Can you
So
speak
if we
into
want
your
it in
microphone?
terms of x, then we just have to apply that trigonometric formula, right?
Sorry, in terms of?
If we want the trigonometric ratio in terms of x instead of 2x.
No, if it was only sine x, then it's a direct formula, na? The differentiation of sine x is cos x. But the thing is, the function here is not simple, na? It is a composite function. X को हमने पहले double किया है, then we have operated sine on it. You understood the point, na?
Yes, sir.
Okay. So see, what will happen is, with enough practice in chain rule, na, you will also be able to skip some of the steps eventually. But right now, I don't recommend that. Okay. Right now, I recommend that you apply the proper steps. So for example, for this function y is equal to sine 2x, or for a general function y is f of gx. When you apply all the steps of chain rule, you can see that dy by dx comes out to be differentiation of f of gx multiplied by g prime x. Okay, so you can apply that directly over here. You can see that this is what your g is and this is what your f is. So with enough practice, you'll be able to see that this f prime, so f is sine. So what is f prime? It is cos, you know, differentiation of sine is cos. So it is cos of gx. Now what is gx? It's 2x. Okay, multiplied with g prime. Now g is what? 2x. So g prime of x is how much? 2. So you'll be able to come to this step directly. So you'll be able to look at this function and say that, okay, it is f prime of gx. So this f prime term is cos. But what is gx? Gx itself is 2x. So it is cos 2x into 2, or 2 cos. So when you practice enough number of questions, you can skip some of the steps in the chain rule application and do this directly also. but I don't recommend doing that immediately. Okay, first you practice at least the questions which I've given you in the worksheet, as well as the questions I've given you from the module as part of the assignment for this week. You practice those questions using all the steps correctly and properly in sequence. Then you will come to a position where you'll be more more well versed with this, and you can directly do some of these steps like this over here. Okay, so I'm now moving on to some more questions which I've received on the text message. Okay, yeah, Arun, you calculated the question correctly. That was good. Okay, Sambhavi has asked a question: with the help of differentiation of root of any variable having power greater than 1 plus a number, will help with differentiation of root of any variable having power greater than 1.
So I meant to say that root of x square plus 1 or x square plus 2 or x cube plus 4, like these numbers.
Okay, so you mean a composite function which has square root of something which has a power series of x inside it, right?
Yes, sir.
Yes, so definitely for that we have to use the chain rule, no? Yes,
Okay.
right? Okay. Anandita, you have asked, in the previous rule stated that derivative of e raised by x is e raised by x itself. How do we identify when to use that rule and when to use chain rule in case of e raised to some power? Okay. No, so the thing is, see, the fundamental function is this one. The fundamental function is e raised by x, and the differentiation of this function is e raised by x itself. This is the property of the function e raised by x. Or you can understand it like this, that fx, if that is e raised by x, then derivative of fx is how much? It's e raised by x. But then suppose I have something like this, that I have e raised power of some other function gx. So for example, I had e raised power sine x. Now I'll take a different one. Suppose I have e raised power of x squared plus 2x. So you can see that this function is now this. So accordingly, what will become the derivative of y with respect to x? It will become f prime of gx into gx, no, by into g prime x, and by the chain rule step. No? So f prime is what? E, but e is raised to what power? E is raised by g only. Okay, so this will become the case now. So for a general function like this becomes the derivative. Okay. So in this particular case, that g is this one. So dy by dx will become over here e raised by the same power x square plus 2x, but now that has to be multiplied with g prime x. So the derivative of this is how much? 2x plus 2. So this particular function will have a derivative like this. 2 into x plus 1 I can take common into e raised power x square plus 2x. Just like in the previous example we had done, the power was sine x, so it became cos x into e raised power sine x. Okay.
Yes, sir. Thank you.
So hope that clears your doubt, Anandita.
Yes, sir.
Yes. Okay. Yeah, Hitesh, assignment 1, question number 1b. Okay, I'll come to that. Sai, you have asked if you could, I guess you're saying discuss homework question 1, 2, and 3 of exercise 3. Yeah, sure. We'll discuss those questions. Okay. Okay. So based on the messages I've received, okay, so far I've received only one doubt in assignment 1 or worksheet 1, which is question number 1b. So let's go through that once. Okay. Just give me a moment. I'll pick up the assignment 1, go through that question. Right. So I'm sharing assignment 1. So question number 1b, that is the question I've been asked to solve. Let's go over that question. So Hitesh, this part, right, you were asking that how we have calculated the total time of motion until it finally stops. So actually this is not calculus, this is use of This is use of basically a kinematics concept that we know. So what is happening is that a particle, it is starting from rest at time t equal to 0. So that means we'll take the initial velocity as 0 at t equal to 0 time. Okay. And its speed increases uniformly at the rate of 2 meters per second square. So we can say that its rate of change of velocity or acceleration is equal to 2 meters per second square from t equal to 0 to t equal to 10 seconds. Okay. So during this time, what we can say, what is happening is that the velocity can be, or at least we can write the speed as u plus at. We don't know whether the motion is straight line or not, so it doesn't matter. So we'll talk in terms of scalar quantities. So v is speed over here, it's not velocity. A is magnitude of acceleration. So the acceleration is actually a vector, and s we'll take as distance similarly instead of displacement. Okay. So v is equal to u plus at, so that will give us that velocity as a function of time is 2t, and s is equal to ut plus half at square. So in this part, I don't need the second equation actually, but so this will become t square as a function of time. So that's happening, and then after that, what is happening in the second part? After 10 seconds, it's decelerating uniformly at 4 meters per second square. So for t greater than 10 seconds, what is happening is that the acceleration, this time we can write it as a prime, that is minus 4 meters per second square. So for this part of the motion, we can say that v is equal to u minus 4t, like this kind of equation we have to use. Okay, so now we have to visualize that what's happening in the first 10 seconds, your speed is increasing, and in the next few seconds, your speed is decreasing. So for this part, we have to find out the total time. So total time is obviously 10 seconds for the acceleration plus some amount of time for the deceleration. How much time it takes to decelerate to come back to 0? That's what we have to understand. So you are following my discussion so far, Hitesh?
Yes, sir.
Okay. So what's the easiest way of doing this? One of the easiest ways to analyze this data is to just understand the graph. If I draw the graph of speed versus time, okay, I can't say this is velocity versus time because I don't know it's a straight line motion. But at least I can say that as far as speed versus time is concerned, what is happening in the first 10 seconds, the speed is increasing like this uniformly with respect to time at the rate of acceleration of 2 meters per second square. So how much the speed will become at 10 seconds? It will become 20. V is equal to u plus at, right? So this is in seconds and this is in meters per second. So this part of the graph is clear.
Yes, sir.
Now next time देखो क्या हो रहा है 10 के बाद it's decelerating at the rate of 4. So again it should be a straight line but with decreasing thing. Okay. So a prime should be equal to 4, or we can say with sign minus 4 meters per second square. So let's say this time interval, this is some delta t. So what is happening during this delta t from t equal to 10 seconds to whatever time I have over here, let's say this is t2. So from t equal to 10 to t equal to t2, the initial velocity in this interval was how much? 20 meters per second. The final velocity at the end of t2 is how much? It's 0. And the deceleration is how much? It is 4 meters per second square. So from that we can understand what this delta t time is. Okay. So we can say that v minus u divided by delta t, that should be equal to the acceleration. Right? This step is clear now?
Yes, sir.
So 0 minus 20 divided by whatever this delta t is, that should be equal to minus 4. So that is telling me what is my delta t? It is equal to 5 seconds. That is telling me what is my t2? It is 10 plus delta t. Okay. So it is equal to how much? 15 seconds. So that's how you know the total journey from start to stop, that is equal to how much? That is 15 seconds. That's the total time of the journey.
So can you do question for C of this one?
Okay, we'll discuss. Okay. So what is the average speed for the entire journey? Okay, so the time you understood now. So this part is done. Now what is the average speed for the entire journey? So average speed हम कैसे define करते हैं? Total distance upon total time, right? So for this part now we have to calculate total distance divided by total time. Now total distance I don't know yet, but total time at least I know is 15 seconds. Okay. Now without using too much formula, from what I already have on the board, can you tell me what is the easiest way of finding the total distance?
Area under the graph.
Yes, very good. That's the easiest way. So this total area will be equal to the total distance. Right. So all of you are familiar with this concept that if you have a speed versus time graph, then the area under the graph. So here area is very simple. Half of base. So this is 15 seconds. So 15 seconds into height. Now this height is 20 meters per second. You can see that 150 meters is the total distance. So here this answer should now become how much? It should become 150 meters divided by 15 seconds. So it should be 10 meters per second. Okay. I'll show you a formula based method also. But since we've already drawn the graph of V versus T, I don't need to use any separate formula. I can just get the information from the graph itself. Okay, so hope this is clear. Okay. Now another thing I could have used to calculate the total distance was I could have used this information that from 0 to 10 seconds, our initial velocity was 0, our acceleration was 2 meters per second square. So the distance traveled in this part was, let's say, S1. So S1 will be equal to half ET square. So 1 by 2 into 2 into 10 square. So it should be equal to 100 meters. That's the distance traveled in the first part. And then from the earlier part, I know that from t equal to 10 to 15 seconds. Okay. For that interval, what was the initial speed? It was 20 meters per second. The final speed was 0. And the rate of deceleration was equal to this. So we can use this relation that v square is equal to u square plus 2as. So if this part has a displacement of s2, it will be v square minus u square upon 2a prime. So when we calculate that, you'll see that this comes out to be so this comes out to be 50 meters. So you can see the total distance traveled will become, so for this C part, the net distance will be S1 plus S2. So that will become 150. So that's another method we could have used. Okay. So hope that clears this question fully. Okay. Now moving on, I have also a request from Vineet to discuss question 4C of assignment 1. So I'm moving on to the next page. And the next. Okay. So question 4C part, let's look at this next. Calculate the instantaneous speed at t equal to 15 seconds. Okay. So you can see here that in this interval from 10 to 20 seconds, this is a straight line graph. Okay. So it's just a matter of observation that from t equal to 10 seconds to t equal to 20 seconds, S versus t is a straight line. So what that tells us? That tells us that the speed is uniform. For this interval. Only for this interval, not before that or not after that. Okay. So when the speed is uniform, the average speed for the interval is equal to the instantaneous speed at any point of time between this, which is equal to delta S by delta T. So delta S by delta T, you can calculate from this that at the end of the interval, it is 300 meters. At the beginning of this interval, so this is my delta S. Okay. And this is my delta T. It's basically this slope. So 200 by 10 or 20 meters per second. Okay. So hope this is clear. Vineet Lunia, question 4C is clear, I hope. Okay. So before we come to the other questions, just looking at this graph more closely now, you can see what you can analyze about this graph just by observation of it is, if you draw the tangent at a point like this, if you draw the tangent at a point like this, is the same as the straight line itself. So that's why it's having uniform speed. But for example, if you draw the tangent at a point like this, and then again draw the tangent at a point like this, then again draw the tangent at a point like this, you can see the slope is increasing. So this part from here to here, it has an increasing speed. Whereas this part we saw, it has a uniform speed. And then again, this part you can see, if you draw the tangent here and compare it with the tangent here, the slope of the tangent is decreasing. So this part has a decreasing speed. So that was the main thing you have to pick up about the question, that this part has uniform speed, this part is decelerated, this part is accelerated, and this part has come to rest. Okay, here the motion is decelerated. Here the motion is with uniform speed, and here the motion is accelerated. This was at that stage, this is all I wanted you to analyze from the given graph. Okay, so that is about assignment 1, I guess. Okay, so let's come to some of the other questions. Right, so coming back to your messages, next thing we'll discuss. Okay, now number of you have asked me some questions from the module, particularly exercise 3 and exercise 1. So I will come to that. Okay, but before that, does anybody have doubts from worksheet 3? Before you come to the module, from the latest worksheet which I have given, the third worksheet last week. Oh, Arya, you have also asked question 1E from. Okay, Arya, your question is from which assignment? Question 1E from from assignment 1 only. Okay. Okay, so for a moment we'll go back to assignment 1. Okay, so let's come back to this question. How much is the average speed for the last 10 seconds? Okay. So for that, the best way to analyze is again use the graph. We had made a graph of velocity versus time. And we saw in that graph that for the first 10 seconds, it's accelerating and going up to 20 meters per second. And then for the next 5 seconds, it's decelerating and coming back to 0. So in this now, what is the last 10 seconds of motion? This is the last 10 seconds of motion. So this is the last 10 seconds. So for this interval of time, okay, I have to calculate average velocity. Okay, so this part is from t equal to 5 to 15. So that will be the distance divided by the time. Okay, so for the distance, I can break it into two parts. I can take this distance plus this distance. So if this distance is, let's say, S1, so now you can see from the graph, you can understand that the velocity here is 10, because this is the midpoint of these two. So S1 will become what? The area of this trapezium, that is half sum of parallel sides into perpendicular distance between them. So this is becoming how much now? Half of 30 into 5. So 75 meters, correct? Okay. And this triangle is having area S2, let's say. So that is half of base into height. So that is 50 meters. Okay. So the total displacement will become S1 plus S2. So 75 plus 50 divided by the total time, which is 10 seconds. So you can see 12.5 meters per second is the average speed. Okay. So Arya, I hope this is clear to you.
Yes, sir. Yes, sir.
Okay. Okay. Fine. So I think we are done with. Okay. Very good, Vineet. Good to hear. Okay. So I have received a couple of doubts from us worksheet 3 also. So let's go over those first. Then I'll come back to the module assignment doubts that you have asked. Okay. Just give me a moment. Yeah, so this is worksheet 3. Does anybody have a doubt in the first question, any part, any of these?
Sir, can you solve the first A, sine square x?
Sine square x. Okay, so let's look at this. So sine square x, now, interestingly, we can solve in two ways, because one is we can always interpret sine square x as sine x into sine x. So we can use product rule. Okay, but that's an odd way of solving it. The easier way of solving it is that you understand that for y equal to sine square x, what we've done is on x, we have first operated sine. So we got sine x, and on that we've operated whole square function. So we got sine square x. So it's a composite function. So you can think of this as your gx, and you can think of this as your f of gx. Okay. So what you can do here is, if you go by the chain rule method, the first step you will substitute. So you take z as sine x. That's your dummy. So your y becomes how much? It becomes z square. So then you apply your chain rule step, that dy by dx is dy by dz into dz by dx. So y is equal to z square. So dy by dz is 2z, and z is sine x. So its derivative is cos x. So resubstitute z as sine x. So you see you get dy by dx as 2 sine x cos x, which by the way can also be written as can also be written as sine 2x. But it's not necessary. You can just leave it as 2 sine x cos x also. So this was the first thing. You find the derivative itself. Now next thing is you want to find the value of the derivative at which point x equal to pi by 6. So I want to find dy by dx at x equal to pi by 6. So that is 2 times sine pi by 6 cos pi by 6. Now you know pi by 6 is the same thing as 30 degrees. Okay. So it's 2 into half into root 3 by 2. So it's root 3 by 2. So your final answer should be root 3 by 2.
सर
Yes.
ये प्रोडक्ट रूल से कर सकते हैं ना, sin square x को sin x the whole square लिख के sin x into sin x square.
Yes, we can also apply product rule and you will get the same thing by that also.
हाँ सर सेम आया.
Yes, correct. Okay. So there are two methods of doing this particular question, right? So as you have suggested, we can also do this. We can write y as sin x into sin x and then just apply product rule. So it will become derivative of first function, which is cos x, into second function, plus first function into derivative of second function, which is again cos x. So you can see that this is 2 sin x cos x. Okay, na? So hope this is clear. Okay. So maybe you have a doubt in the D part, right? So let's discuss that. So this is a typical example of you have to use the chain rule method over here. Okay, there is no other option for us. So y is equal to square root of 1 plus x square. So you substitute z as 1 plus x square. So y becomes square root of z, or you can say z to the power half. So next step, so differentiation of z to the power half is how much? 1 by 2 root z. And differentiation of 1 plus x square is 2x. So it becomes x by root z. So by re-substitution, that becomes this. So this is your derivative. Dy by dx is x upon root of 1 plus x square. Now the final step, you want to find the value of the derivative at x equal to 2. Substitute x equal to 2 here. You get 2 upon square root of 1 plus 2 square. So 2 by root 5. That becomes the answer. You can leave the answer in terms of square root. You don't need to calculate root 5 and do the division and all that. Okay, so this is a typical example of chain rule. Yeah, somebody this clear, beta?
Yes, sir. Yes.
Okay, very good. Okay, so
Yeah.
Sorry, come again, beta. I can't hear you clearly.
Sir, last time in the notes you had given a direct formula for y is equal to 1 plus under root 1 plus n square. So if we did with that, is it okay?
Direct formula as in I derived this by chain rule only, na?
Yeah.
Okay, so yeah. Okay, now next, Soham, you have asked for 1b, and Arya, you have also asked to confirm the answer of 1b. So let's look at that. Maybe something is confusing about 1b. So 1b, now here see we have no option but to use the quotient rule. Okay, so in this we'll use quotient rule, that if y is some numerator divided by denominator, then dy by dx should be denominator into differential of numerator minus numerator into differential of denominator divided by denominator square. So let's apply that over here. So dy by dx will become denominator, which is 1 plus x square, into derivative of numerator, which is 2x, okay, minus numerator, which is x square, into differentiation of denominator, which is 2x, okay, divided by the denominator, which is 1 plus x square whole square. So this will give us 2x, okay, plus 2x cubed, right, minus 2x cubed, okay, divided by 1 plus x square whole square. So that's giving us what? Is giving us 2x upon 1 plus x square whole square. So this is dy by dx. Now we want to find the value of dy by dx at x equal to, what is it, 1. So substitute x equal to 1. So what we'll get here? We'll get 2 divided by 2 to the power 2, so that's 4. So we should get half. Oh, so there's a correction in the answer key that I've sent. It should be plus half and not minus half. Okay. So just note down the solution if necessary. Okay. In the answers that I've sent, there is a mistake. There's minus sign over here. It should not be there. It should be just plus half. Okay. So we've done B part, we have done D part. Okay. Om, you are asking question 5 of this worksheet only, no? Right. Jinendra, you have also asked for question 5. Okay. So let's go through this. So before we come to question 5, any doubts in the second question? Yes, I will solve question number 5, Aryan. Coming to this, okay. Now in second question, I just wanted to mention one thing. For this question, for the part A, you can directly use the identity that this is this. So obviously dy by dx is 1. You don't need to differentiate the whole thing, sorry, is 0. You don't need to differentiate the whole thing to show that it's 0, okay. You can just, since you know that sine square x plus cos square x is 1, you can see that y is a constant. Okay. Anyhow, let's move on. Okay, what about question, the remaining questions in this second question or third question? Any doubts in this?
Question E, मतलब 2E.
Question 2A.
E.
Sorry, which one? Come again?
E.
E. Okay. So again, for that, now it's a lengthy question. You have to just use quotient rule. So dy by dx will become denominator, right? That is 1 plus x square into differential of numerator. So differential of x minus 1 is 1. Okay. Minus numerator, that is x minus 1 into derivative of 1 plus x square, which is 2x, divided by the denominator whole square. So now we have to just patiently solve this. Okay. So this you can see will become minus of 2x square plus of 2x. Correct. 2x square minus 2x with a minus sign, so it will become. So this becomes 1 plus 2x minus x square upon 1 plus x square whole square. So this is dy by dx. Okay. So this is just like lengthy algebra, nothing else. Like it's direct application of this formula. This formula. Hope the steps are clear. Okay, anything else on this page? All right. So let's come to the next one. So unfortunately, I made some mix up with the numbering. So there are two question number 3s. Okay. The total paper should have had 6 questions instead of 5. There are 2 questions labeled as 3. Anyway, the second one is pretty easy, I think. Okay, so it should be very easy. It's a direct application of chain rule. Fourth should also be easy now, especially today we have already discussed how to differentiate sine square x earlier. All right, so let's come to fifth one, which number of people have asked. So let's understand the fifth question. Just a moment. Yeah, where were we? Question number 5 we want to discuss. Okay, so what is happening in question 5 is that you're pumping gas into a cylinder which is initially empty at t equal to 0, and you're pumping it at a rate of, now it's a variable rate where t is time in seconds, and the rate of pumping is given in gram per second. So it is mass of gas pumped per second. And also right from the start, when you start pumping at 4 plus t, this rate, there is also leakage, and from the leakage, gas is leaking out at a uniform rate of 2 gram per second. So all this information has to be used. Okay, so you're pumping in at this rate. Okay, initially it is empty, and right from the beginning when you start pumping, there is also leakage at a uniform rate of 2 grams per second. So let's see how we can make use of all this information to solve the various things here. What is the net rate at which mass of the gas in the tank increases as a function of time? So that's the first thing we'll see, and then of course total mass and all that. Okay, so let's put together the information we saw. So let's say we take mass of gas, okay, or you can say instantaneous mass, that is at a particular instant of time, that we are taking as the variable m in grams. So the first information that we have is that m is equal to 0 at t equal to 0 because it was empty initially. That is the first information we have. Okay. The second information we have is that at any time t, okay, the rate of change of mass with respect to time, okay, this should be equal to what? This should be equal to the rate of pumping in gas.
Yes, sir.
Okay, but also along with that, there's also leakage happening. So it should be minus the rate of leakage, because leakage results in mass decreasing, no? Whereas pumping in results in mass increasing. So this was given to us as 4 plus t. It's a variable rate, whereas this is given as 2 grams per second. It's decreasing at a uniform rate. So dm by dt, the rate at which the mass of gas is changing in the container on the cylinder, is 2 plus t. The net rate of change is 2 plus t. This rate is in gram per second, where t is time in seconds. So it's a variable rate. It's like the person who's pumping in, he's constantly increasing the rate of pumping. At t equal to 0, it was 4 grams per second. By the time you're coming to t equal to 1 second, it's become 5 grams per second. By the time you're coming to t equal to 10 seconds, it has become 14 grams per second, like that. Whereas the leakage is happening at a constant rate of 2 grams per second. So the net rate of change of mass, okay, that is given by this function. So that is the answer to the A part. This is the net rate of change, instantaneous rate of change of mass with respect to time. So hope this is clear to all of you. Okay. Now we have to find the mass as a function of time. So if you have done calculus before, you will realize that one way of doing that is to use integration, but I haven't taught integration yet. So obviously we will not use integration here. We'll just understand it this way, that the rate of change of mass is what type of function? Linear function. So differentiation of m with respect to time is linear. That means m has to be what type of function? It has to be a quadratic function. Like we done one question earlier. Remember in that assignment that it was given that dy by dx was some quadratic function and we have to solve for y. So what was the assumption we started with? That y is a cubic function, because when we differentiate, the power reduces by 1. तो यहाँ पे m कैसा function है time का? इसमें maximum power of t is 1 ना? So it's a linear function of time. So that means dm by dt is linear. That means m should be what kind of function? It should have one more power. So it should be having power of t, maximum power of 2. So that means it should be a quadratic function. Okay, so that's how we will start the second part. Okay, so hope the first part is clear to all of you. Any doubt, please let me know. Yes, perf, very good, that's correct. Yeah, Sambhavi, now you understood how we got 2 plus t, no? It's the net rate of change of mass. So logically, it is what? The rate at which we are pumping in gas minus the rate at which the gas is leaking. Is it clear, Sambhavi?
Yes, sir.
Yes, okay, very good. Okay, so now let's come to the second part. So for the first part, we've already got that the rate of change of mass is like this. Okay. So you can see that dm by dt is a linear function of time. So what that implies, that m should be a quadratic function of time. So suppose m is equal to at square plus bt plus c, where a, b, c are unknown constants. Okay. So the first thing we'll make use of is that m was 0 at t equal to 0. So that means what should happen? C should be 0. And the second thing we'll make use of is that dm by dt was equal to 2 plus t. So I'll just write that as t plus 2. So this now means that the differentiation of this function, which is now at square plus bt, that is equal to t plus 2. Because I already know c is 0 from this. Okay. So I've already got the result that c is 0. Now using this, I'll get the values of a and b. So from this, we'll get what is a and what is b by solving it this way. That now differentiate the left hand side. So differentiation will be 2at plus b. So this should be equal to t plus 2. So that means 2a should be equal to 1. Coefficient of t is same, and b should be equal to 2. So that means a should be equal to 0.5 and b is already 2. We got that. So coming back to this, so now that means that m, and we already got c is 0, is equal to 0.5 t square plus 2t. This is how mass is changing with respect to time. Okay. Or you can even write it as or whatever. I mean the same thing. All right. So hope this is completely clear. Okay. Okay, so next let's come to some of the assignment questions that, I mean, the module questions that you have asked. Okay. So let me try to go in sequence. So all of you, please open the PDF of the module if you have it. Okay. Calculus will be page 25 onwards. So the assignments will be somewhere around page 30, I guess. 30, 32, something like that. Okay. So the first question I have been asked, let me go back to the earlier. Question 1, 2, and 3 of exercise 3. Question 1, 2, and 3 of exercise 3. So all of you just go through that. I'll explain the question. Oh, before that, I also have from exercise 1, question number 19. Okay. Okay, so let's start with that then. Exercise 1, question number 19. So just go through the question. I'll put it up on the board in a moment. Okay, so exercise 1 from the module calculus, question number 19. Just read through the question and try it. I'll discuss it in a moment. Okay, so this is on page 38 of your module. So question number 19 of exercise 1, it's given that y is equal to 1/4 of tan raised power 4x. This is the question. Y is equal to 1/4 of tan to the power 4x. And all we have to do is we have to find dy by dx. We have to differentiate the given function with respect to x. Okay. So here, of course, I can write it as tan x into tan x into tan x into tan x, but that will make it very lengthy. I'll have to use the product rule 4 times. So better is I interpret it as a composite function, that on x, I have first operated tan to get tan x. Okay. And then I've operated the power 4 function to get tan to the power 4. So if I go with that method, I can use the chain rule step. So take z as tan x. So y will become 1/4 z to the power 4. And now just use chain rule. Okay. So try to complete this yourself. Okay, use these steps and complete it and verify the answer if you can.
Sir,
Yes.
sir, can we take tan 4x as t to the power 4?
As what to the power 4?
T to the
V.
power 4 or any variable
Yeah,
to the power
yeah, that only, no? वही क्या ना z to the power 4 ले लिया मैंने इसलिए.
4. मैंने
You
वैसे
can
set
replace z with some other variable also.
Yes,
And
sir.
that 1/4 is just a constant, so it doesn't matter.
Yes,
Basically,
sir.
y is equal to some constant into some variable to the power 4, and that variable itself is what? It's tan x. So chain rule application, you know.
Yes, sir. Wait.
Now just apply the next step and you'll get the answer very easily. Remember, differentiation of tan x is what? sec square x.
I got the answer.
Yeah, very good. Okay. Okay, so finish this question, and if you've done that, then next we will do exercise 3, question number 1, 2, and 3. Okay.
So exercise 3.
Okay, people. So hope you have finished solving this, all of you. So in this, we should get dy by dx as tan cube x into sec square x. Finally, when you substitute here, right, is what you should get. So this will become z cube into sec square x, and that's how that will become this. Okay. Okay, very good, Vineet. You have done this. Okay. Okay, so let's come to exercise 3, question 1, 2, and 3 first. Then we will come back to Arya, your question of exercise 1, and also Sambhavi, your questions from exercise 2. Okay, now in exercise 3, these type of questions we have, they are like an indirect application of chain rule. So let's try to understand. Okay, So for example, the first question in exercise 3 is saying that a circular disc has a given radius of 3 centimeter. Now it's being heated, and because of thermal expansion, the radius is increasing at the rate of 0.05 centimeters per second. So that you can understand is a very small rate. It's like half a millimeter per second. So we have to find the rate at which its area is increasing when the radius has already become 3.2 centimeters. So let's understand this question. So exercise 3, question number 1. Okay. So let's interpret it like visually. So you have, let's say, a disk which has at some time t, it has a radius equal to r. Now because we are heating it, it's expanding very slowly. So after some time, or you can say after a very short time, its radius would have expanded by a very small amount, which is dr. So at a new time of t plus dt, the radius has become r plus dr. Okay. Now it is given to us that this rate at which the radius is increasing, this is equal to half a millimeter per second. And that's what it's given us, 0.05 centimeters per second. So this is given. Rate at which the radius is expanding. That is given as this. Okay. So now we want to find out the rate at which the area of the disk is increasing. This we want to find out. At an instant when the radius is given to us as 3.2 centimeters, and of course the rate of increase of the radius is also given to us as. Okay. So this is a practical application of chain rule. You can understand here what is happening is that area is a function of radius. Okay, and radius itself is changing with respect to time because it's an expanding radius. So when we want to find dA by dt, we'll have to use chain rule. Okay. So we have to use the concept that A is equal to pi r square. Okay. So rate of change of A with respect to time is going to be rate of change of A with respect to radius into rate of change of radius with respect to time. Because of this thing, A is a function of r and r itself is a function of time. Okay. So the rate of change of area with respect to time will become differentiation of pi r square with respect to r into differentiation of r with respect to t. So this is 2 pi r into dr by dt. So that is equal to 2 pi. Now at this particular moment we want to find out. So we'll substitute this data here now. Okay. So at that moment when the radius is exactly 3.2 centimeters and the rate of increase of radius is exactly 0.05 centimeters per second, this will become this into 3.2 into 0.05, and see what the unit will become. This is given in centimeters and this is given in centimeters per second. So the area is changing three two pi in centimeters square per second. That is the rate at which the area is expanding. Okay, so this is the concept in this type of a question. Okay, just go over this carefully or make a note of it if required. Okay. Now we'll use a very similar method for solving the second and third question also. Okay. So if you have understood this and taken down the key steps, then I would suggest you try out question number 2 of exercise 3 next. Okay. Try to use the same kind of method, the same kind of steps yourself. Yes, very good, Vinith. You have got the idea correct. Okay. Yes, that's correct. I'll go over it once. Okay. Okay, good, Sambhavi. Correct, Parv. Very good. That's correct, Jinendra. So you can see it's the same kind of logic. Okay, it's this time the difference is that we're talking about the volume of the cube and the edge length is increasing at a certain rate. Okay. So we have a cube whose instantaneous side length is L or edge length is L. So the volume of the cube, that is L cube. Okay. So if this is the situation at t equal to t. Now at a new time, it's expanded slightly. So each of these dimensions, they become L plus dl. Okay. So the volume would also have become V plus dV. So volume being L cube, you can see that dV by dt can be written as dV by dl into dl by dt. So this is 3L square into dl by dt. So this is the formula we will use. Similarly, in this question, we could have also been asked surface area. Okay, surface area, let's say A, would have been 6L square. So rate of change of surface area would have become. So if this had been asked, the answer to this would have become 12L into dl by dt. And now you just substitute the data which is given and you can get the answer. Okay. And likewise, you can try out the third question also yourself now. So this was question 2 of exercise 3. So the third question is like a reverse of this. Okay, is the rate of change of volume which is given to us, because it's given in cubic centimeters per second, and from that we have to find the rate of change of radius of the balloon. So assume that the balloon is perfectly spherical in shape. The spherical shape like this. So if the radius at any instant is r and the volume is v, then you have the relation that first of all volume is given by the formula 4 by 3 pi r cube. Okay. By the way, at a later stage, we'll see how to actually derive this formula from calculus. Why is exactly the relationship of volume with radius this? We'll see that we can prove it by using the second part of calculus, which is called integration. So anyway, so here, rate of change of volume with respect to time will be this, sorry, into dr by dt. So rate at which the volume of the balloon is expanding is equal to, now when you differentiate this with respect to r, you'll see you'll get 4 pi r square into dr by dt. Now in this question, what is happening is that data is in the reverse manner. dv by dt is given to us, that we are increasing the volume of gas or the volume of the gas balloon at the rate of 900 cc per second, and we have to find the rate at which the radius is increasing at the instant when it's 15 centimeters per second. So this quantity is 900 centimeter cube per second at the instant when r is equal to 15 centimeters. So this dr by dt we have to find out. So dr by dt will become 900 divided by 4 pi . Yeah, students, I just got disconnected for a moment. A lot of problems with the internet connection in the last couple of days because of the weather conditions. Just a moment. I have to switch the host conditions. Yeah. Then I should be able to share the screen. Yeah. Okay, so finally we are getting the rate of change of radius, if I'm not mistaken, should come out to be 1 by pi centimeters per second. Okay. So hope these two questions are clear. Okay, very good, Vineet. Okay, now let's come to, somebody had a couple of doubts in exercise 2. Let me just go through that. Yeah, Sambhavi, you had doubts in question number 2 and 5 of exercise 2. So let's do those next. Okay, so if you finish writing this down, next you can go through this exercise 2, question number 2 and 5. We'll discuss these two next. Okay, so let's come to exercise 2. This is on page number 39, okay, of your module. So question number 2 is we have to differentiate 1 upon ax plus b whole square. So let's understand how we can use chain rule concept again. So you want to find dy by dx. Okay. So here it's of course understood that a and b are constants. Okay, they are not variables. It's x which is the variable and y is the dependent variable. So this will again be done by chain rule. Okay, we will substitute a dummy variable as ax plus b. So y becomes this. Okay. So okay. So now you can see that differentiation of y with respect to z will become minus 2 into z to the power minus 3, or minus 2 by z cube, and differentiation of z with respect to x is just a. So this is minus 2 by z cube into a. So on resubstitution, we have minus 2a upon ax plus b whole cube. I've just resubstituted z as ax plus b. So this should be our final answer. Hope this is clear, Sambhavi.
Yes, sir.
Okay, very good. Let's go through the third question next. Oh, sorry, question 5. No, you have asked not 3. My mistake. Okay, so 5 is again that square root of some type of function of x kind of thing. So in this case, it is y is equal to square root of x cube minus 5. Had it been just square root of x cube, we could have directly applied the power rule. It was 4x cube minus 5, my mistake. Okay. But anyway, the same method as we have discussed today, the quantity under the square root, you will take that as your dummy variable. So again, you interpret this, you substitute. So y becomes square root of z, or z to the power half. Okay, so just complete this. Okay, Sai has asked question number 8 of exercise 2 also. Okay, so we'll discuss that next after this. First, just complete this yourself, see if you can get the answer correctly. So ultimately, this will give you right. Okay, let's look at the 8th question. So we want to differentiate the function e raised by square root of 2x. So once again, we will look at application of chain rule. So we can say it like this, that y is equal to e raised by square root of 2x. So we want to find what is dy by dx. So again, we use the chain rule step, that substitute z as root 2x. So y becomes e raised by z. Okay. Now doing this, you can see that dz by dx is just root 2 into 1 by 2 root x. Root 2 is like a constant, so you just take it outside. So it is 1 by square root of 2x. Okay. And dy by dz is e raised by z only. So this becomes the final answer. Okay, so hope this is clear, Sai. Yes, very good, Parv. That's correct. Okay, now a couple of people had asked exercise 1, question number 5. Om and Arya. So let's discuss that. So after you finish writing this down or going through it, let's come to exercise 1, question number 5. Okay, so section 1 of exercise 1, question number 5. It is just a very lengthy type of question, nothing else. Okay, so we'll discuss that. So in this, now they're using a different variable. Z is given to us as this kind of function, x square plus 1 upon 3 times x square minus 1, and then plus x square minus 1 into 1 minus x. Okay, so first is we can simplify this a little. Okay, we can simplify and make it this x square minus 1 into 1 minus x can be written as x square minus 1 minus x cube plus x. So that is x square minus x cube plus x minus 1. Okay. Now to find dz by dx, what we can do is first we can think of this whole quantity as y, let's say. Okay. So z is equal to y plus x square minus x cube plus x minus 1. So dz by dx will become dy by dx plus differentiation of this whole term. Yes, okay. Now let's find dy by dx, and for that we can just use the quotient rule. So take 1 by 3 outside and apply the quotient rule. So denominator multiplied by differential of numerator minus numerator into differential of denominator divided by the denominator whole square. So this kind of thing is just about patience, okay? Patience while solving this type of a lengthy question. Or you could have just taken the 2x common in the numerator and you'd see that you'd get minus 2. So this becomes minus 4 by 3 x upon x square minus 1 whole square. So that's my dy by dx. Now substitute that back in the z. So dz by dx will become dy by dx, which is minus 4 by 3 x upon x square minus 1 whole square plus 2x minus 3x square plus 1. Okay, so hope this is clear. So Arya and Om, hope this question is clear to both of you. Vineet, you have solved this correctly. Okay, so since these are the doubts that you people have asked, let me we finish these questions now. So let's work out another question, which is a little bit more lengthy version of application of chain rule. So just try out this question. So y is equal to square root of natural log of x square. So find dy by dx. Just try out this question, people.
So y is equals to
Square root of natural log of x square. This function ln of x square, the whole thing square root. Remember we had discussed about the function y is equal to natural log of x. That
yes, sir.
has a graph like this, and differentiation of natural log of x is given by 1 by x. That's the formula for the differentiation. So that same function, we have to find this out for it. Okay. So Parth, Jinendra, and Vineet. Also Per, let me verify your answers. Okay. So again, as it turns out, there are a couple of ways we can do the question. One is that we can simplify it a little. Okay. So we can use the property of log that any base log of a to the power n can be written as n times log a. Okay. So using this property, ln of x square can be simplified as 2 ln x. So if we do this, this question becomes much simpler. So y is equal to square root of ln x square can be simplified to, okay, so this root 2 can just be treated like a constant, and the function is really this. So this is the easiest way of dealing with the question. So if we do this now, this is a constant, and this is that f of gx type of thing, where f is square root and g is ln. Okay. So very simply, we will substitute z as ln x. So y becomes 2 root z. So dy by dx. Oh, sorry. It becomes square root of 2 into square root of. My mistake. So this will become square root of 2 into 1 by 2 root z into dz by dx, which is differentiation of ln x. Okay. So as you can see, dy by dx simply becomes 1 upon square root 2 into x into root of z, which is ln x. Or we can simplify it a little bit further and write it as 1 upon x square root of 2 ln x. Or we can also write this as 1 upon x square root of ln of x square. Because now we are using this in reverse. Okay. That 2 ln x can be written as ln of x square.
Sir, we could have just applied the chain rule 3 times, right?
Twice.
Yeah, we can directly also apply chain rule. That's correct. Okay, but here also I have applied chain rule. But before applying the chain rule, I have simplified it a little. I have replaced ln of x square with 2 ln x, which makes the whole thing bit easier, isn't it? You understanding the point?
So instead, when I did it with like the chain rule twice, so everything just got cancelled because x square
Yeah.
derivative was 2x, and so the 2 from there and the 2 from the derivative of the root, that got cancelled, and the x got cancelled with the 1 by x square.
No. Then you made some mistake in the solution. I'll show you by the other method also. You get exactly the same. Okay.
I got the
You'll
same
get exactly the same answer, whichever way you express it, this way or this way.
Yes,
You'll
sir,
get the same.
solution.
Sir,
Sorry?
I got the same
Yeah.
solution.
Same solution, then it's fine. Yeah.
sir,
Yeah.
I got the same solution, but I did a mistake. That's why I got ln x to the power 2 and to the power half.
Okay.
So that was a
So you
mistake.
understood the mistake, no?
Yes, sir.
Now, first of all, before we come to the other method, are you all clear with this property of ln, how we used it, property of log?
Yes, sir.
This is clear, no? This step? Yes. So there are some important properties of log that you should know. Okay. Log of a into b is log a plus log b. That's the first property. Then very similarly, log of a by b can be expressed as log of a minus log of b. Okay. And the third property is this one, that log of a to the power n is n times log a. And a can be any real number. So it can be, for example, minus half also. It can be plus half also. It can be 2. It can be minus 2, anything like that. So in this particular case is this. So this property we've used here. So basically, yes, obviously with chain rule, you can differentiate any function like this. But if there's an opportunity to simplify the function using some property, whether that's a trigonometric property or a property of log or whatever, you should try and use that first, because simplifying will make the number of steps less. Okay. Anyhow, so let's see what we would have done if we had not simplified first. So we can also interpret this function like this, that okay, let's take z as x square. Okay. So y becomes square root of ln of z. So it's still a composite function. So next, let's take ln z as some new variable, let's say u. Just like here we have taken a dummy variable. So y becomes square root of u. So this becomes our relationship that y is equal to u to the power half, where u is equal to ln z, where z is equal to x square. So there are three steps involved here. From x, we are doing the whole square function to get z is equal to x square. Then we are applying the ln function to get u is equal to ln of z. And then we are applying the square root function to get y is equal to square root of u, which is basically this complex function. Okay. So now when I use chain rule, because y depends on u, u depends on z, and z depends on x. So I'll have to use three steps in my chain rule. It is dy by du, because y depends on u, okay, into du by dz, because z now depends on, u depends on z, okay, and into finally dz by dx, because z depends on x. So this is like an extension of the chain rule. Now one extra variable is there, and rest is then just algebra. So we'll just apply this. So dy by dx is differentiation of u to the power half with respect to u, okay, multiplied by differentiation of ln z with respect to z, okay, multiplied with differentiation of x square with respect to x. We're just substituting these here. So that becomes 1 upon 2 square root of ln x square, right? Because that is what so that further becomes, now substitute z. So that becomes 1 upon square root of ln x square into 1 by x square into x. Which you can also write as 2 ln x using that same property. Okay, so this is another way of solving the same question, but as you can see, this is a little bit lengthier because I have not simplified. I had the opportunity to simplify the function in the first place by replacing ln x square with 2 ln x. So that would not have required that extra substitution, but I've not done that over here. So I need an extra substitution, and so my chain rule has the link between three variables. Y is related to u, u is related to z, and z is finally related to x. That is from differentiation, but some maybe differentiation of differentiation of u to the power half is 1 by 2 u to the power half minus 1. Okay. So that's how we got this.
Sir, I was asking when we substituted lnz as u.
So y is what? Square root of ln z, na? So u को ln z लिखा है ना? So that's understood now. So the above formula, y is root ln z. Just replace ln z with u. So y is becoming square root of u, right?
Okay.
Okay, so this is like an extra lengthy version of application of chain rule. Anyhow, so that completes today's session, and with this, you should be able to differentiate any and every given function to you Okay, so I'll give you some more assignments, and with that practice of that, differentiation should not be a problem. So next lecture, we will start looking at more applications of differentiation.
Yes, sir.
Like we saw some applications today, you know, like the problems where the sphere is expanding or the radius of the disk is changing. So accordingly, the area is expanding. So those type of practical applications of differentiation. And we will also see how to predict the properties of functions like maxima, minima, etc. Using differentiation. So some interesting things related to application of differentiation coming up in the next lecture. So until then, wish you all the best, people, and thanks for attending. That's it for today's session.
Thank you, sir.
Thank you, sir.
Sir, I use the chain rule method, but hello. Sorry. Okay.
Sorry, come again. What were you saying?
Sir, I used
Yeah,
the
that's
same chain rule method, but like mine was done in much lesser time. So like it took me just 2 steps to do the entire thing.
so fine. Now maybe you skipped one of the steps of the substitution. That's fine. You can always do the steps directly as long as it doesn't you don't make a mistake. That's the only thing you have to be careful about. Okay.
So like just a second, like I'll show you what I did.
Okay.
I'll just.
Okay, sharing by this thing is disabled in my thing. Okay, so
No,
just
sir,
send
I'll
it to
send
me.
you a
Yeah,
file.
yeah. Send it to me on WhatsApp. Now I'll check it
I'll
out.
send
Just
you
okay,
a
beta.
file in the chat, image in the
Okay,
chat.
just send it to me on WhatsApp later. No? I'll check it out. Just okay,
Okay.
beta. Okay.
Thank you,
Okay.
sir.
All
Bye,
the
sir.
best.
Bye.
Okay. Okay. Bye, beta.